Welcome, Mass Detectives. Today we've got a case that looks, well, pretty much impossible. But trust me, with the right clues, we are going to crack this thing wide open.
Okay, let's get right to it. Our first mystery is to find the very last digit of this absolutely enormous sum. I mean, look at it. It looks super intimidating, right? But don't worry. Every great detective needs a secret code to get started, and we've got one.
All right, first things first. Our main clue is this strange-looking exclamation symbol. We've got to figure out what it really means. Let's investigate. So this symbol is called a double factorial. And, it kind of looks like you just do a factorial of a factorial, but nope. It's actually something totally different. It's a special kind of multiplication that works one way for even numbers and another way for odd numbers. It's actually pretty simple once you see it. For an even number, like 6, you just multiply all the even numbers down to 2. So, 6 times 4 times 2. For an odd number, like 7, you multiply all the odd numbers down to 1. That's 7 times 5 times 3 times 1. See? This one little clue splits our whole investigation into two different kinds of cases. Let's use this new tool to crack our first one.
We are on the case. Our mission: find the units digit of this huge sum of even double factorials. Now, obviously, we can't calculate the whole thing. That would be crazy. So we're going to have to look for some clues.
Let's start gathering evidence. We'll just calculate the first few terms. So, 2 factorial is just 2. Our first units digit is a 2. Easy. 4 factorial is 4 times 2, which is 8. Okay, next up, 6 factorial is 6 times 4 times 2, which equals 48. We only care about that last digit, so that's an 8. Then we've got 8 factorial, which ends in a 4. So far, our pattern of digits is 2, 8, 8, 4. Not super obvious yet. Let's see what the next term shows us.
Okay, the next term in our list is 10 double factorial. Now, let's write it out. It's 10 times 8 times 6. Wait a minute, stop right there. Do you see it? That 10 at the very beginning? Anytime you multiply a whole number by 10, the answer has to end in a 0. This is the breakthrough we've been looking for.
This pattern is our master key. I mean, think about it. What about 12? It's going to be 12 times 10 times 8 and so on. It has a 10 in it. 14 will also have a 10. Every single even double factorial from 10 factorial all the way up to 2022 factorial is going to have a 10 in it, which means their last digit is always 0. This makes our case so much simpler.
So here's the solution. Since every single term after 8 factorial ends in a 0, we can just ignore them. They don't change the last digit at all. All we have to do is add up the units digits we found earlier. 2 plus 8 plus 8 plus 4. That adds up to 22. And the last digit of 22 is, of course, 2. And just like that, we've cracked it. The units digit for our first mega mystery is 2. Excellent work. So, you ready for another case, detective? All right, let's dive into case number 2. We're going to use the same detective skills, but this time on a brand new mystery, finding the last digit of a huge sum of odd double factorials.
Time to gather some clues for the odd numbers. Okay, 1 factorial is just 1, and 3 factorial is 3. Now, 5 factorial is 5 times 3 times 1. That's 15. So the units digit is 5. What about 7 factorial? Well, that's 7 times 5 factorial, which is 105. Hey, the last digit is 5 again. Let's try 9 factorial. That's 945. Another 5. I think we've just found our pattern.
Once we hit 5 double factorial, there's a 5 in our multiplication. And here's the cool part. Every odd double factorial after that, like 7 double factorial or 9 double factorial or 11 double factorial, will also have to multiply by that 5. And any odd number multiplied by 5 always ends in a 5. It's a rule. So every single term from 5 double factorial all the way up to 2023 double factorial has a units digit of 5.
So this is the final piece of our puzzle. We've got our first 2 units digits, 1 and 3, and after that, we have a whole long string of 5s. We just need to figure out exactly how many of those 5s we're adding up.
So how many 5s are we dealing with? Well, we need to count all the odd numbers starting from 5 all the way up to 2023. And if you were to count them all up, which, trust me, we did, it turns out to be exactly 1,010 of them. That's a lot of 5s.
Okay, so the sum of all our units digits is going to be 1 plus 3 plus whatever we get when we add up all those 5s.
And the quick way to do that is just 10 times 5. So what's the last digit of that big multiplication?
Well, think about this. 10 ends in a 0, right? So when you multiply it by 5, the answer is also going to end in a 0. That means the last digit of all those 5s added together is just 0. So our final sum is super easy. It's just 1 plus 3 plus 0, which equals 4.
And there's our answer. The last digit is 4. We've solved the second case. Seriously, you're becoming a pro at this, detective.
Okay, before we close the case file for today, let's go over the powerful techniques we used and officially add them to your Math Detective Toolkit.
Think about how we used these. We took a huge, scary problem and broke it down into evens and odds. We hunted for those patterns and found the 0 clue and the 5 clue. We didn't waste time trying to find the whole answer. We just focused on the units digit because that's all the question asked for. And we weren't scared by that weird double exclamation point symbol. These tools right here will help you solve pretty much any math mystery that comes your way.
You've proven today that you have what it takes to crack the toughest cases. So keep your eyes open for clues. Always look for those patterns and never, ever stop investigating. Until next time.